All right, it's 12:12, so let's go ahead and begin. First question, use your unit circle to find the arctangent of negative square root of 3. I'll give you 3 minutes, try it on your own, and then we'll go over it. All right, to do this problem, where my pen? There it is. Do this problem, where you need to look for is remember that the tangent, uh, tangent of an angle gives you a ratio of y over x. So the arctan then takes a ratio of y over x and it tells you the angle that produces it, where that angle has to be between negative pi over 2 and pi over 2, which are your angles in quadrants 1 and 4. So what we're looking for is where on the unit circle is y divided by x, the negative square root of 3. Because it's negative, we need to have an opposite value for our y or x, which means it's going to have to be one of these options in quadrant 4. And if you want the square root of 3 to be in the numerator, your best bet is to use this one, where the square root of 3 is for your y value. if we try evaluating that, the negative square root of 3 over 2 divided by 1 over 2, you find that this actually, if you simplify it, becomes negative square root of 3 over 1, which is just the negative square root of 3, like we want. So this right here has a ratio of y over x of negative square root of 3 like we want. However, that angle, 5 pi over 3, is not in this range. It is 5 pi over 3 is not between negative pi over 2 and pi over 2. But you can fix that really quickly by taking 5 pi over 3 and subtracting 2 pi to find its coterminal angle, which turns out to be negative pi over 3. All right, questions on this? Oh, and then it's always not a bad idea to go ahead and verify your answer with the calculator. So according to our calculator, this arctan, oh, I need to change this back to radians. The arctan of negative square root of 3 is negative 0.1047. And if you do negative pi over 3, you see that that's the same decimal. All right, questions about the bell work? Okay. What could also help you for these problems is if you Google tangent values on the unit circle, the first image that shows up has all of your y divided by x ratios already set for each of the angles. So then you don't have to work it through by hand. You could just pull the answers from your graph here. All right, then what we're going to do today is finish 4.7, which is evaluating compositions. So now we're going to take a trig function and its inverse and combine them together. It's not too bad as long as you get the notes down. So the first type of compositions that we'll do is a function and its inverse. And you would think that a function like sine taken of its inverse, because they're opposite operations, would cancel out and leave you with your value. And you are right that that's what happens. However, arcsine is not a perfect inverse operation to sine, because remember, we had to limit the domain and range of arcsine. So as a result of that, they operations will only cancel out if you're taking arcsine and your x value is in the domain of arcsine, or if your inside function is sine, the y value in there is in the range of arcsine. So only if your x or y value is in the domain or range will these operations actually cancel out. If your x value is not in the domain, then that just means this function is undefined. And if your y value is not in the range, that doesn't necessarily mean it's undefined. That means you'll just have to work it by hand. So what you will need to do is copy down this whole thing. because that same rule, same idea applies to cosine and tangent. Cosine and arc cosine only cancel out if it's in the domain and range of arc cosine. And remember, the range of arc cosine is 0 to pi. Tangent and arctan only cancel out if it. The nice thing about tangent is, remember, the domain is all real numbers, so you don't really have to worry about that. But the range is the numbers between negative pi over 2 and pi over 2. Again, not including the endpoints. So I'll give you a minute or two to write this down, and then I'll do some examples. All right, does anybody need more time to write? A little bit? Okay. All right, all right, all right. Okay. So to do these problems, you're going to refer back to your notes pretty often. Let's look at some examples. So if I want to find the tangent of the arctangent of -5, the first thing I'm going to do is I'm going to check, is this value in the domain of arctangent? Go back. Domain of arctangent is all real numbers. So since Rx value is a real number, then we can use our inverse property, and the tangent and arctangent operations will cancel out, and the answer is just -5. To do this one, arc sine of 5 pi over 3. I'm going to see, can I use my inverse property? So I'm going to look at this. is 5 pi over 3, which would be a y value, since sine is the inside function, is that in the range of arcsine? And no, it's not. 5 pi over 3 is not between negative pi over 2 and pi over 2. So this will not cancel out. So instead, I have to work this one by hand. To do this by hand, the sine of 5 pi over 3, the y value at that point on the unit circle is negative square root of 3 over 2. And then if I want to do the arc sine of negative square root of 3 over 2, I then look for what angle in quadrants 1 or 4 produces that y value. And the nice thing about these problems is you already found it. This is the angle that produces that y value. But again, that angle is not in the range. To make it fit in the range, we have to subtract 2 pi from it. Which gives us negative pi over 3. So the arc sine of the sine of 5 pi over 3 is negative pi over 3. To do this last one, same idea. I'm going to look, are these inverse operations? Will they cancel out? So I'm going to look at my value of pi. That's my x value. Is that in the domain of arc cosine? And the answer is no. Pi is not between negative 1 and 1. So because pi is not in the domain of the inverse cosine, then this answer is undefined. Pi is not in the domain of the inverse cosine. And once you're done with your problems, don't forget you can check these answers with the calculator. If I do the tan, arctan of negative 5, you get negative 5. I do sine, or sorry, the arc sine of sine of 5 pi over 3. You get negative 1.047, which is the same thing as negative pi over 3. And if you do the cosine of the arc cosine of pi, answer is undefined. All right, so any questions about these examples? All right, then let's have you try some. Tell me what these three composite functions are. I'll give you 3 minutes, and then we'll go over it. All right, so if we work through these problems, tan inverse of negative 14. I'm going to check, is negative 14 in the domain of arctan? Yes, because the domain of arctan is all real numbers. So these are inverse operations, and they will cancel out, leaving you with just negative 14. If you want to do the sine inverse of sine of 7 pi over 4, is 7 pi over 4 in the range of sine inverse? Nope, because it's not between negative pi over 2 and pi over 2. So then I have to work this problem by hand. If I use my unit circle at 7 pi over 4, my y value is negative square roots of 2 over 2. And then if I want to find what angle produces that y value, well, it is 7 pi over 4, but again, that's not in the range. To get it in the range, we just subtract 2 pi from it, which would be negative pi over 4. For this last one, is 0.54 in the domain of arc cosine? Yes, because 0.54 is between negative 1 and 1. So then these operations will cancel out and leave me with just 0.54. If we double check our answers with the calculator, you can see that we did do it correctly. Good job, us. Questions about any of these problems? Do we feel okay about this? Do you want to see some more examples or ready to move on? Okay. All right, all right, all right. All right, we'll move on then. Okay. Now we're going to try composition of functions, but of different types. So for example, let's take the tangent of the arc cosine of 2 over 3. Here is how I would recommend you approach this problem. You have to recognize what information it's telling you. So as a reminder, the cosine of any angle tells you the x over r value. So then the arc cosine will take a ratio of x over r and give you an angle. So what this problem is telling me is that my x value is 2 and my r value is 3. Okay, hold on. That's like the worst right triangle I've ever drawn in my life. Okay. So what this problem is going to do is when we take the arc cosine of 2 over 3, it's going to tell me what this angle is. And once I have what that angle is, I'm going to take the tangent of that angle. And the tangent of your angle is y over x. So my final answer is going to be y over x. I know what x is. X is 2. That was given to me. I don't know what y is, but I could find out what y is really quickly. How would I do that? I know this side's 2. I know this side's 3. How do I find the third side of a... Yeah, Pythagorean theorem. X squared plus y squared is r squared. So if we plug in 2 squared plus y squared is 3 squared. 4 plus y squared is 9. Which means y squared is 5. Which means y is the square root of 5. And I know that y is going to be positive because we did arc cosine. And remember, arc cosine gives me angles in quadrants 1 and 2, where y is always positive. So my final answer then is the square root of 5 over 2. Note that when we were doing this problem, I never actually found out what that angle is. I don't actually care what that angle is. It could be 20 degrees, it could be 32 degrees. It doesn't matter to me because that angle is just a stepping stone to getting us the final answer, which is a ratio. So all I really care about is what is the ratio I'm finding. And again, the nice thing about these problems is you can quickly verify your answers in the calculator. If we type in the tangent of the arc cosine of 2 over 3, 2 over 3, you get 1.118, which is the same thing as the square root of 5 over 2. All right, questions about A? All right, then let's try B. So arcsine, what does arcsine tell us? That tells us y and r. So this is telling me y is -3 and r is 5. And again, when I take the arcsine of -3 over 5, I will get an angle. And when I take the cosine of that angle, I will get the ratio of x over r. And again, I already know what r is. I just need to find x. And how do I do that? Pythagorean theorem. So if I plug in, we'll have x squared plus -3 squared equals 5 squared. means x squared plus 9 equals 25, which means x squared is 16, which means x is 4. So the answer is 4/5. Again, if we type it in to check out, cosine, arcsine, -3/5, you get 0.8, which is 4/5. All right, questions about B? Or does anyone need more time to write? All righty, then it's your turn. Tell me what the cosine of the arctangent of -3/4 is. I'll give you 3 minutes, and then we'll go over it. Okay. Hey, all right, good job. All right. So again, tangent tells us y over x. So this is telling us y is -3 and x is 4. The arctangent of -3/4, will give us some angle. And to be honest, I don't care what the angle is because I'm going to take the cosine of that angle to get x over r. I already know what x is. I just need to find r. And to find r, we use the Pythagorean theorem. So I do 4 squared plus -3 squared equals r squared. 16 plus 9 is equal to r squared, which means 25 is equal to r squared, which means 5 is r. So the answer is 4 over 5. Way to go. Good job. Okay, so then the next thing that we can do is a slightly harder problem. By slightly harder, I mean, yeah, slightly harder. So now let's do this one. The sine of the arc cosine of 3x. And our answer is just going to be an expression in terms of x. We will solve this exactly the same way as the previous ones. So the arc cosine tells me adjacent over hypotenuse. And I'm going to use that instead of x over r just because since our problem has a 3x in it, we don't want to confuse our variables. So this tells me that the adjacent side is 3x and our hypotenuse is 1. So the sine of the arc cosine of 3x, if I take the arc cosine of 3x, I'm going to get this angle here. And then when I take the sine of that angle, I'm going to get opposite over hypotenuse. And again, I already know what the hypotenuse is, but I need to find the opposite side. And so to do that, I will use the Pythagorean theorem. So again, it's just like we were doing before. It's just we have an x term instead of a number. So if I use the Pythagorean theorem for this problem, I'll have 3x quantity squared plus the opposite side squared is equal to 1 squared. Which means 9x squared plus the opposite side squared is equal to 1. Which means the opposite side squared is equal to 1 minus 9x squared. Which means the opposite side is the square root of 1 minus 9x squared. And note, you can't actually square root this. This is done. You can't square root the 1 and separately square root the 9x squared and tell me the answer is 1 minus 3x. That's not right. If you multiply 1 minus 3x by itself, you do not get the answer 1 minus 9x squared. So this is done. Don't try to actually perform the square root. And so if we plug in, opposite side is the square root of 1 minus 9x squared, and the hypotenuse is 1. So final answer is the square root of 1 minus 9x squared. Dun, 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 dun. So again, it might seem like this is a harder problem, and maybe it is, but it's the same steps as what you were doing before. You use the information they give you from the inverse trig function, to label your opposite, adjacent, or hypotenuse, whichever two parts they give you. And then sometimes it'll help you to draw a picture, but then you're going to just use the Pythagorean theorem to find the third side. The only change from before is your answer is going to be in terms of x rather than just a single number. So questions on this problem? No? Okay. That's the end of class. That was it. That's the last problem. So I suppose you have the rest of the hour here. It's about 13 minutes to work on the homework. If you have any questions while you're working on the homework, let me know and I'll help you out as best I can.